ومن يرعاك لا ينساك دوما كيفما تحيا ومن يرعاك لا ينساك دوما كيفما تحيا. Wait, I said after that 3-minute lecture that I would have a granola bar. Like, you gotta treat yourself to motivate yourself so that you can keep going on and do this grueling task. No matter how much you make it fun with streaming and talking to people and taking breaks, it's not fun at all. So I gotta take my granola bar. I had to, guys. I had to. Girly! Yo! Ollie, welcome back to the stream. How's it going? My one mod. My favorite mod in the stream right now. How you been? Where you been? Let me know. I'm so anxious, bro.
A feel for recursion, so we're gonna do one of the classic ones, namely factorial. Simple.
So we're doing a factorial example for a recursion function, which is a very classic one.
Factorial is normalized in factorial is the product from I equals 1 up to n of I. So in other words,
So factorial is a sum
to
of I going from 1 to n.
and n. So that's how we normally write out the factorial. What is this? Whenever you have one of these big I notations from I equals 1 to n, what do we call them?
Product.
Product.
Yeah.
It's using a for loop. So today we're going to look at how could I do this using recursion. So we can also define.
Assalamu alaikum. Wa alaikum assalam wa rahmatullahi Sahil. How is it going? How you been? It's actually been a pretty long time since you've been here, right? I don't know. But yeah, I have a final. My last final is tomorrow. And yeah, having a chocolate chip granola bar right now. This one is making me anxious. You know, any exam you take, even if you're most prepared, you're gonna feel a little bit anxious. Do you have exams? I hope y'all are done with your exams. Life feels so much better without it, though. I gotta say. I can't wait till it's over. So here's an example for recursion. And my marker is kind of dying out, so I'm gonna have to change that. My bad. I opened the drawer and the tripod fell. First, I accidentally showed my face from the reflection. And now the whole thing fell. Wait a minute. Where is it? Okay. We have a lot of markers here. Should be good. Hi, Plaz S. Daisy. How's it going? Hope you're good. Yeah, it makes sense to use a black one. So we're doing recursion. Recursion. Oh wow, that marker is really good.
This is n factorial equals. Okay, so I had this problem. I want to know what the factorial of some number n is.
You have EOG tomorrow? We got science. Yeah. I have an exam tomorrow.
Well, since you're here is n factorial, let me express this in terms of a different factorial. So that's what equation is all about. Taking a large problem, so I want to know what n factorial is, and express it in terms of another smaller version of the same problem. So then in factorial, we put something smaller than n. Oh, okay. If I knew what n minus 1 factorial was, that's smaller than n, right? That's an easier problem. Then can I go from n minus 1 factorial to n factorial? Sure. N minus 1 factorial is all of these values, right? So if I knew n minus 1 factorial, I just have to multiply by n, and then I know what n factorial is. So I can write out n factorial as n times n minus 1 factorial. So I've written this larger problem, this n factorial problem, into an easier, smaller version, so n minus 1, of the same problem. So namely the n factorial problem, still just a smaller version. And then eventually we want to get down to a case where it's so small, where n is so small that we know what the answer is. So what do we know? We know that if I have 1 factorial, what's the answer there? 1 factorial is just 1. And then also we define 0 factorial to be 1. So that's our really easy case. That's the one where we can say, oh yeah, I know what the answer is then. So I'm going to write down that 1 factorial equals 0 factorial equals 1. So that's when I know the answer. Okay, so then let's take a look at how would I code this. Same function. So I'm trying to write a my factorial function. I give it the n that I want to know the factorial of, and it's going to have one output variable that's, okay, this is the answer for n factorial. I'm going to have an n out. That's my answer. And my function is my factorial. I'm writing my own factorial function that takes in an n that I want to know the factorial of. And I guess I'll maybe be good here and try to do a little bit of error checking in my function to make sure that this n that gets passed in is okay. So if I'm trying to talk about factorial, what's allowed for n and what's not allowed? We don't really usually talk about the factorial of negative numbers, so I probably want to check if I was passing one of those and kind of yell at the user if that was the case. So I'm going to do a check. So if n is less than 0, then I'm going to put out an error message. What else would be bad for the factorial function? So when we write it out here, n factorial, we're basically assuming
Integers.
integers.
Yeah.
So n is less than 0, or so then I want to check if it's an integer. So our standard absolute value of the floor of n minus n, so that difference is too big. It's bigger than, I'll just say 1e minus h, so some epsilon. So if it's not an integer, I'm going to print out an error. So f printf, we'll just say
Not floor, round. Yeah. All right, so those are the two conditions that we're using for the factorial function that we're making so that it works, because we don't take factorials of negative numbers or decimal points. So what's not a decimal point? Anything that's an integer. So this is an integer. This is the condition for an integer. This is the or. This is the negative. No, why is it or? Shouldn't it be and? Anyways. Why is 0 factorial 1 but 0 to the 0 power undefined? Oh my gosh, Oscar, that is such a very good question. Because it's a calculus thing. There's a proof for it. And I did it too. I forgot it by now.
valid input. And we'll print out a percent %d, go back to gen, and then whatever they gave me. And so since I kind of want to just be done at this point, I'm just going to assign my output variable to some sort of nonsense value that will hopefully let the person that called my function with that input know that this doesn't make any sense. So I'm going to assign it -1 because that's not a valid value for the fact. Okay, so I've taken care of that sort of base case, right? In the sense that I'm not doing any recursive calls in that case. So that was sort of the error part of the base case. What about when they give me good input? What about my base case? So my base case is when it's
Wait.
base. So done at this point. I'm just going to assign my output variable to some sort of nonsense value that will hopefully let the person that called my function with that input know that this doesn't make any sense. So I'm going to assign it -1 because that's not a valid value for the factorial.
Wait, why did you put an out equals that?
To some sort of nonsense value that will hopefully let the person that called my function with that input know that this doesn't make any sense. So I'm going to assign it -1 because that's not a valid value for the factorial. Okay.
So whoever is gonna call the function should know that this doesn't work. So that's why you do it. But it's not a comment or anything. Anyways, that's just an example I have to put underneath this thing.
So taking care of that sort of basic
Because it's when you call the function, the call function should be under, but we don't call this one, so we put a nonsensical thing in the bottom.
case, right? In the sense that I'm not doing any recursive calls in that case. So that was sort of the error part of the base case. What about when they give me good input? What about my base case? So my base case is when it's easy, I know the answer, and I'm not going to recurse. So factorial. What's the easy case? When do I know the answer? I know the answer when n is 1 or
One
0. Okay, so
or zero. Yeah.
that's in my base case. So else if so n equals 1 or n equals
The general function was an if for base case and an else for a general case for the recursion part. But else if she didn't go over that, but that's just another condition for the if function. So else if is under that, but only the else part is for the general case. So for example, the one that we do know for the base case should be something like where n is 1 or n is 0. So n equals 1 or if n equals to 0. But I don't know why that one has two equal signs. Oh, never mind. They both have two equal signs. Okay.
0.
Because when you're assigning something, the argument is just one equal sign. But if it's two equal signs, you're saying if it's that number specifically, not assigning it, you know?
That's really my base case. The first one was too, but I
Yeah,
was
that's the base case.
my base case. And what do I want to do? Well, my base case, that's when I'm not recursing. So here I know the answer. So n out is just 1 in those cases. All right, so then I have an else. So this is
So this is just the output. When n is 0, you take the factorial of either one, the output is just 1. And it makes sense. This is the nonsensical one, so this one is the yeah.
my general case.
This is your general case for the else one.
Here, I'm still assigning something to my n out. So what did we say? Our n factorial, that's what my n out is. He's the answer for n factorial. We decided that I could express him as n
Times n
time
minus 1.
this one is. So I'm either going to go and write my factorial.
So this is your factorial. N is the one that you're trying to do. This n factorial part is the my factorial. And then n times n minus 1 factorial.
So I'm going to call myself just on a smaller simplified version of the same problem. So now I'm handling the n minus 1 case. And that's easier than trying to figure out what factorial of n is. Okay, so that is a recursive function. And everything up here. And there we go. So like we saw, it's typically split up into an if to check to see if you're in.
Okay, so the general case is when we write that you know how function a factorial is n factorial is equal to n times n minus 1 factorial. So the n minus the n times n minus 1. The n part, the n factorial part is the my factorial that you're making. So it's my factorial times n minus 1. But that's your output. That's just an out. But make sure it's like aligned with this. Anyways, I have to put it aligned. N out equals to my factorial times n minus 1. And there's no factorial afterwards. That's the n factorial part that you're multiplying it with. And then yeah, semicolon.
Base case, here I have an error.
Okay, but also you have to end it. You have to end it. So this is the if statement, right? You have the else if, the if, and the end. But then you have to do it again for the main function. Like that.
as well. And if you're not, then you're in the general case, and that's when the recursion is going to happen. You're going to call yourself on a smaller version of the same problem. Okay, so I want to take a look now at what actually happens if you were to sort of run this code. So let's pretend that I wanted to figure out what my factorial of, I don't know, say 5 is. So let's say I called my factorial, passing in 5. Okay, so we'll come in, and is 5 less than 0? No, so that's not true. And I'm checking for an integer, and yeah, 5 was an integer. Okay, so we go down to the else if, and then I'm checking, is it equal to 1 or equal to 0? No, I'm not in the base case, so that means I'm in the recursive case. So then I'm going to assign my output to be 5, that was my n, times a call to my factorial where I'm passing in 4. So this call here is going to generate a 5 times
4.
my factorial where I'm passing in 4. So it's going to generate a call where I'm passing 4. Okay, so we kind of like put this on hold here. We know that when we call the function, we jump right into that function. So here, when I call it with a 4, I would jump right in, and there'd be a 4 for my n. Again, I'm not in the bad case here. So then I drop down here, and no, I don't know the answer yet because it's not 1 or 0. So I'd be in the general case, and it says, okay, I need to calculate whatever my n was, but now I've passed in n equal to 4. So this is going to generate.
And then it goes to 3, and then to 2, and then to 1, and then you get your answer. Because if statement is a loop. If
But at this point in time, my n was 4. So when I do 4 minus 1, I'm going to generate this 50. And what the output actually get to the alt. I'm going to return this. And I know to whoever calls me, which was this stop, and pass back out as my fat. No, I can finally do this 3 times, and now I know the answer is 2. So 3 times 2 is 6. So I'm assigning n out gets plus 6, and it's an ant time, or which will be ant 20. So we sort of, you kind of go all the way down until you can solve the base case, and then everything sort of filters back up until you have the final answer at the top. So that's a classic example of recursion, mainly doing a recursive version of the factorial function.
there you go. We just mastered the recursion example. That's just one example. But instead of or, I usually put and. No, I think or is better because you can have either. All right, so we're done with that. Well, before I erase it, let me just study it first a little bit. So your input is here, the end part. That's your output here. This is your function name. This is your if statement. If statement starts off with a base case, okay. But before the base case, because we're using the base for else if, we have to check if the input is even valid. So it can't be a negative number for factorial, and it can't be something that's not an integer. So if it is either one of these, we have to print out that it's an invalid input. And then we go on to the next one if it passes this one. And we say that, okay, let's do the base case, check if it's that. And then we get 1. We have to write the outputs here. Don't forget the output. N out equals -1, N out equals 1. And then N out here for the last part is my factorial times N minus 1. And you don't have to put anything else because it goes to that loop again. And there you go, you have it. Very, very. I wish that was my whole exam, bro. We need a break. We got the basic structure down. We got the example down. So what is it? The basic structure includes an if statement. Check, base, general. Output here, input here. Out, in, out, in, out, in. In and out, but backwards. Start with out, and then in. This is the out, this is the in. The outer variable, the inner variable. This is the name. Does that make sense, guys? Y'all ain't paying attention. Y'all falling asleep. I had an eraser, man. Like a bigger one. Where is everything when you need it? Oh, there it is. Oops, I mean, I gotta go. Ew! No! But thanks for popping in. Gotta go. I'm a bit, just wanted to stop by since I haven't joined the stream in a few days. Maybe like 15 minutes. Okay, that's nice. You gotta go in 15 minutes. Oh, okay. I thought you said you're gonna. Alright. Well, how you been? Let me know. We're just going over recursion, which is like, um, sort of programming type of thing in MATLAB. It's the bane of my existence right now. Like, I don't want to do this, but I have a final tomorrow. Like, I should have done this already. I should have watched this already, done the example already, all by myself without any problems before. So the final was not supposed to be so hard, and I was supposed to go to office hours if it didn't make sense if I couldn't do it on my own. But I didn't do any of that, so I might fail. But that's because I'm shy. Like I'm too shy to go to office hours. How have you been? I've been stressing. I ain't gonna lie, I've been stressing. Very stressful. But I'm done with most of my stuff. Like this is the only thing left. So after this, I can finally start studying my own stuff. Very excited. I have a lot planned. I'm gonna study a lot, even during spring break. Because personally, I like studying. I just don't like being forced into studying. But also, I feel like I would have not had a problem watching the lectures doing this kind of stuff that I should have been doing earlier if I had my own room. But that everyone keeps saying that I'm just making up excuses. Like my whole family's saying like you have the room to yourself every day at certain hours. But not while I have school. Wait, my professor just graded something really important. Let me see. Didn't do too bad on it, but whatever. Hopefully I get a good grade on my final project. I have a 94 in the class for that one. Hope it doesn't go down more. Oh my god. All right, let's watch this lecture.
All right, let's go ahead and do another example. So this one is going to be the Fibonacci sequence.
Fibonacci sequence.
So again, state. Okay, so that's how you get the Fibonacci sequence. So can you think about how we could define this recursively? Okay, so I'm going to say that this can be defined recursively, and Fibonacci manipulated t number as Fibonacci n minus bigger than or equal to 3, because then I'd be adding the second one plus the first one.
You're adding
So
some. Fibonacci sequence is like 1 plus 1 plus 2 plus 3 plus 4 plus 5. So 1, 2, 3, 5, 8, dot dot dot. So when you define it recursively, the sequence is n minus 1 plus n minus 2 for the fact for the Fibonacci sequence of a specific number. So it goes all the way down. You're adding all of it until you're done with all the terms. For all n greater than or equal to 3.
The first Fibonacci number, the Fibonacci of 1, we defined it up here. I'm defining it to be 0. And the other one that I know is Fibonacci.
Because you start with 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1, 3. 2 plus 2.
So we defined Fibonacci of n in terms of itself, but smaller versions, easier versions of itself. So now, this is kind of what we did before, factorial. But do you see anything different here compared to what we had with factorial? So when we talked about n factorial, it was just n times n minus 1 factorial. So there was only one other factorial on the right-hand side. How many Fibonacci's do I have on the right-hand side? I have 2. So Fibonacci generates 2 recursive calls. So we make that in general.
What?
But when we talked about n factorial, it was just n times n minus 1 factorial. So there was only one other factorial on the right-hand side.
Well, for Fibonacci sequence, that's 2.
Fibonacci generates two recursive calls. So let's say, note that in general,
In general, Fibonacci has two recursive calls,
two
which is
factorial
n-1 and n-2.
generates
I think for even and odd, right?
two more calls to it.
Why? Why two?
Do it. Okay, so that's the idea. So let's go ahead and try to write some code for our Fibonacci function.
Oh, because it's like an increase, yeah.
So it's just one output, and we can notice the answer if I want the nth Fibonacci number. Then out all this.
Okay, let's write it. Let's write it. How have you been? I hope so too. Um, yeah, how have you been? I don't know if I asked you, Arrow. How have you been? Do you have any exams? Function. The output is n out equals my Fibonacci. Let me spell Fibonacci. Fibonacci, and the input is n. Again, if statement. If I don't know if there's any conditions for. I guess it does have to be a factorial, but it has to start from 0, so it can't be less than 0. It can't be negative. It's the same conditions that we did in the previous example. The capstone project is graded A in the class from my other. Oh, thank God! Thank God! I was so worried. I got an F the whole semester, and then in the end, it's whew. But that's just one class. I gotta worry about the rest. I'm so worried. It's fine. It's fine. It's not in my hands. All right. So if the term is negative, what does that mean? What's the condition we put? I forgot what we put for the last one, but anyways. Or if round n minus n is greater than I e to the minus 10e to the minus 8, 1e to minus 8. I think those are the conditions. I'm not exactly sure, but we'll see. She's gonna go over it right now.
It's too big.
If n is less than 1, no, floor works in many cases, but round works for all cases. Okay. You have to do the absolute value as well. I forgot about the absolute value. Oh my God. And it has to be less than 1. I'm cooked. How did I not know it was supposed to be less than just 1? Been good just working on some essays and big papers and whatnot. Yeah, man. You got this. You got this. I did that capstone project for. I'm so happy, man. Alhamdulillah. Just gotta let that sink in a little bit. Alright, but do not forget about the absolute values. I forgot about the absolute values. But for Fibonacci sequence, it has to be less than 1. Because it makes sense. You know, you can't do a Fibonacci sequence of 0, right? 0, yeah, it has to be at least 1. And then you take the absolute value of round. Not the actual absolute value, but the parentheses absolute value of round n minus n in parentheses, right? Or no parentheses. Round n minus n is greater than 1e to the minus 8. All right, and then f print f invalid input percent d backslash n and n. There you go. Yo, Lagan, how's it going? I'm so sorry, I don't know Chinese, but I could tell that's Chinese because I practiced a little bit of Chinese when I was a kid, and I learned only one word. That's this. Do you, it looks like an eigenvalue inside parentheses, but it's supposed to be fire in Chinese. Does that make sense? Does that look? Can you read that? Fire in Chinese. See? Cool. Cool. Can you see that? Cool. Teach me some Chinese words, bro. That's the only one I know. Fire, yes. See? I get you. I get you. Teach me some kung fu, man. Like Bruce Lee. It was Bruce Lee Chinese. I think he was. Jackie Chan. All right, so we did our check part of the if statement. Now we need to look at the elif statement. Oh, actually, first we need to put the out. And out. Uh, a wrong example of an out is probably like -1 again. And then for the else if function, else if we want to go over the base case. What is the base case here? Well, if n is equal to 1, do we just put n out equals to 1? I forgot what else we do. Like, I literally just did this and I forgot already. Yeah, it's supposed to be just n equals to 1. Yeah. Okay. So we're done with that. And then for the else function, n equals to 2 or something. Right? Not n. N out. No. N. She has n over there. Oh, actually, we'll put n out for here. For the bottom, n out. That is C program? No, it's actually MATLAB. They don't use the actual program for the lectures. It's insane. Like, why would you not use the actual program so I could learn a little bit? But they have to type out the whole thing. And the previous lecture, the previous professor did that too. I thought it was just his teaching style, but it's actually everyone's. And I don't know why. So, yeah. It's frustrating because I don't really understand that easily. But it's okay. Lagan, how's it going? Do you have exams? Are they easy for you? Are you a straight A student? Are you struggling at all? Do your parents actually invest in your studying instead of like, I don't know, making you do chores while you're supposed to be studying?
Equals 1, I know the answer is 0. So n out equals 0.
Oh, 0. If n equals 1, the output is 0, right? Because Fibonacci, if n equals 1, then you have the Fibonacci of 0 plus n minus 2. 1 minus 2 is -1. Plus 1 is 0. So you have to calculate it already. You have to make sure to understand the Fibonacci sequence has 2 terms. She went over that. The factorial has 1 recursion. This one has 2. Let me just put it over here, right? Fibonacci of n. This is a formula, right? Fibonacci n equals to Fibonacci n minus 1 plus Fibonacci n minus 2. Fibonacci n minus 1 plus Fibonacci n minus 2 for all n greater than or equal to 3 for all. This is the for all function, right? This is our formula we're working with. So the n out for the first one is just -1. Yeah, for this one, it's 0. This is not an example. This is the output and out, right? It's common. It's supposed to be self-explanatory when you put n out equals to something. So this is the output when you calculate it, but it's not. So common sense is not common, right? You don't see that because you don't have that common sense. So n out is 0, but now you do. Now it doesn't matter where you were, Matt, because listen, nobody is ever dumb. All right, you either familiar or you're unfamiliar with something. That's all. That's what I tell everybody who's struggling, who thinks something is hard. It's not hard. You just have to familiarize yourself with it. That's it. MATLAB, I know that. Really? You're so lucky. How'd you learn it? Did you, Lagan, did you, uh, learn it on your own? Like just because you were bored? Or did somebody force you to learn it? Gotta go to practice in a few minutes. Will you be streaming later tonight? I think so. I have to really lock in today, so I'll try my best. I will definitely stream. And yeah, take care. Have a good day, and hope practice goes well, inshallah. So yeah, this is your output for the base case, the else if. Now, we're done with the checking if it's okay, if it's an all right output. We're done with the base case, and now we just have to to cover the else function. And the else function, you don't put the condition here, put it under. N equals to 2 or more, could be anything. But for example, it says 2. Then the out and out is equal to, well, let's see. Fibonacci 2 minus 1 is 1. Fibonacci 2 minus 2 is 0. So the output is just 1. And you have -1, 0, and 1.
Okay, and unlike last time,
Okay, bye.
I
Good
kept on my base case
to
as
see you.
perfect.
Good to see you too, Arrow. See you later.
Because Fibonacci of 1 is 0, but Fibonacci of 2 is 1. So I better go ahead and check to see if I'm in my other base case. So else if
It is another base case? Wait, what even makes something a base case? I'm confused now. She said other base case. There's more than one. Yo. I don't want to do this anymore. I'm done. Cut the show. Real study experts would laugh at my study technique. You know what I mean? Like Chinese people, how do they lock in? How do you study? I need to see an actual expert in studying. They just lock in. They don't yap. They don't. All they're doing is focusing, like deep work. I could say I wish that were me, but I honestly don't know if I wish that were me. I mean, I do wish to pass, yeah, but I still want to be myself. You know? I feel like everything got sucked out. Like you're done. There's no personality. You're just a computer. I love failure. Failure is human. You know the computer. But this becomes an else if function now because we have another base case, apparently.
So this is a second base case. So we're allowed to have more than one. So
As
let's just
if
send
we
our
don't have enough
for
problems
else
already. We have a second base.
Okay, so that was my base case, or two base cases. So otherwise,
So base cases are always 0 and 1, right? That's crazy though. The last example that we went over, it didn't do. Oh, it did, because 0 factorial and 1 factorial are both 1. So that went over all the base cases. Else if n equals 1 or n equals 0. So those were the base cases for the previous one. We put an or sign here. It's not just or for this one. It's also for this one. So the factorial one was actually simpler than this one. It's pretty crazy, huh? Wow. Like this ain't even the hard part. That's crazy to think about. You know what? I feel like next semester I'm gonna be better at studying. Next semester I'm gonna pass all my classes. Hope. Should I take a break? Oh, I'm not even done with part 4. That's crazy. Wait, no, this is the Fibonacci. Okay, okay. We're almost done with this one. Oh wow. One more minute.
General case, or person case. So what do I know then? Well, I still want to assign my
N
elements.
equals 3.
So what's the Fibonacci number? Well, we decided it was going to be
3.
Fibonacci of n minus.
Hold on. The N output is all that? Oh yeah, I forgot. The last one we put my factorial times n minus 1. So that was our actual output for last time. So for this time, what we're doing now is the Fibonacci. So we have Fibonacci n minus this formula already. That's the Fibonacci n minus 1 plus Fibonacci n minus 2. So that's our output. That's the rest of the code. And then we end it. And then we end it again. Not there. This one goes here, right? No, it's actually lined up. So that should be the end.
Fibonacci. But I can define it in terms of easier versions of the same problem. And I will, of course, to get the answer. That is my.
That's it. We did it. We did 2 examples of recursive functions. But now I have 0 viewers. That's pretty crazy. Why did I X that tab, bro? I just want to get it over with. Bisection method. This one is long. This one is 16-minute, bro. So we did that, and now we have one last lecture to do. And then once we're done with this, we could start with the actual lab. Do all of it without looking at any ChatGPT, no help. If we have to take any help, we will. But after that, we have to do the whole example by ourselves, and then we'll be okay. Are you a CS major? I'm not, but my major does require a lot of CS. It's data science. So there's no actual data science majors. It's just applied mathematics and statistics, and the minor is data science. So that's what I'm doing. The minor is what's requiring me to take all these computational classes like MATLAB. But it's actually the major I checked the other day. So this is something that is unavoidable, that you have to take these computer science classes. kind of want to end the stream. I'm not gonna lie, even though I have one more thing, because I don't want to do it. Like, I just did so much work, and but yeah, this is so hard. No, I'm not even doing anything. I'm just trying to understand the concepts, you know. So bisection method. Should we start or should I end the stream and then come back later? Because we've been doing this for 45 minutes. We need to take a break, right? The human brain, let's see. Without showing my reflection. The human brain can only focus for 45 minutes. While the human brain can focus intensely up to 90 minutes, 45 minutes is a frequently cited practical average for optimal concentration before mental fatigue sets in. So, making the 45 to 15-minute rule, 45 minutes of work followed by 15-minute break, as an effective productivity strategy. All right, so I'm gonna end the stream here and we'll be continuing later on after 15 minutes maybe 15 minutes, maybe 5 hours, but we'll continue later inshallah. All right. Assalamu alaikum wa rahmatullahi wa barakatuh. Bye.